Great. Thanks, everybody, for joining us at 9 a.m. on day 3. Thanks for making it this far. We're actually pretty excited about this session. We've been meaning to do this for the last, I don't know, since I've been here, 3 years or so. So this session is the past, present, and future of GKE. I am Gary Singh. One of the product managers on Google Cloud. We have to have AI in every presentation, so this is my wife's work with AI as my photo. I don't like photos, so she AI generated a photo of me, so that's AI in our presentation. Over with me as well, I have Mr. Drew Bradstock. He's in charge of this whole operation, so if you like this session, credit to me. If you don't like it, it's Drew's fault.
That was not what we discussed, so.
That's the way we roll. So our session's pretty obvious. We're going to talk a little bit about the history of Kubernetes, then we'll talk about where we are today, and then where are we going. And with that, Drew, why don't you tell us about the history?
Thank you very much. So in the beginning, there was the monolith, and that monolith became many, many monoliths. And those monoliths, and you all have them still, how much you kid yourselves, that became many, 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 many microservices. So this is one of the key things that Kubernetes helped from that transition from monolith to microservices. Now, fun fact, when I joined Kubernetes or GKE many years ago, GKE itself was a monolith, which I'm like, this is the most ironic thing ever. We're pitching microservices, and it's a massive monolith with the low and slow launch process. That is no longer the case, and our launch velocity is actually quite quick. So it's pretty incredible, actually, how far we've come. If you look where containers began many years ago at Google, to actually, it's been almost 10 years to the day, plus minus module 2 months, 10 years of Kubernetes from that first code commit on June 6th, which is frankly incredible, and GKE is turning 9 this year as well. We were the first managed service coming at the gate, and Kubernetes and GKE is literally the age of my kids. Thankfully, Kubernetes can handle much more math processing, and listening to instructions my children can, and hopefully they won't listen to this later. From there, though, hold on, there. The heart and soul of Kubernetes, though, is all of you. If you look at what it has made it successful, it's the fact that we have a really vibrant community. We are actually now over 314,000 commits to Kubernetes, making it the second largest OSS product other than Linux, which is incredible. Building on that, we've actually seen 7,800 different companies contribute to Kubernetes. This is not just a Google thing. This is really a community that spans the world, and you can see this at events like this, as well as with KubeCon. All that said, though, Google remains the heart and soul of Kubernetes. We're the largest contributor by far. This is something that we feel strongly of having an open cloud with an open framework that can handle any workloads that we can throw at it. Fundamental to why a lot of customers choose GKE is the fact that Kubernetes is built, tested, developed, and deployed on Google hardware. That means on day 1, when all the releases come out, it's already gone through a massive test cycle on our systems, and then the community can benefit from that in partnership with us. And that's why we really feel that if you're looking for the best Kubernetes offering that you have, you should work with the people who know it best, contribute the most, and are actively developing with it. Gary?
Great. I guess we should have started off, or I should have started off asking a question. How many of you are using GKE today?
Thank you.
Excellent. Thank you very much. And then I guess, maybe even if you're using GKE, how many of you think or have heard that Kubernetes is hard? Actually, this is pretty good. We like this crowd. Well, so we'll go through these sort of quickly, but as you kind of look at, we've started to look at, what are all the different layers, if you will, and sort of like the whole Kubernetes platform, if you will. And there's been sessions on platform engineering, right? Obviously, and as you go from bottom to top, right, the top is really, at the end of the day, where the value is, right? I was talking to one of the initial people from Kubernetes. I said, what if we had something like, Minikube on day 1? Right? Maybe people would have just focused more on like the high level, the portable API, building apps, building deployments, building services, rather than necessarily getting involved in all the plumbing. We can see the substrate down at the bottom, all your compute, everything in there. Then we're going to run wherever you run on hardware, Google Cloud, et cetera, provider-specific API. And then we're going to have a whole layer of sort of policies, sort of govern to that. It's a lot of gorp, if you will. And while that provides value from a technology perspective, it's not really where the value is from an end user perspective or from a consumption perspective. So what have we been doing on the GKE side, right? We've been trying to figure out, do you want to manage all of this stuff for you? Now, how many of you ever ran open source Kubernetes? Good. So some of you had that pain, but others.
Many are still managing OSS Kubernetes themselves. Okay, so I see 1, 2, 3 honest/brave hands. So thank you.
As you start to look at it, like how much of that, do you really want to manage, right? And I think that's where we start to look at kind of adding that value. So on the GKE side, where, since GKE came out in Kubernetes 2014, GKE, I think 2015, right? Yep. The first version of it, right? Can we take all this bottom layer, right? Handle all the orchestration of GCE compute, nodes, hardware, networking, et cetera, right? Implement all the stuff that integrates that in there, right? That's obviously the sort of key value. Can we then add a whole management layer, right? Things like, policy, network security, et cetera, and then just leave to you kind of this top layer, right? And that's really where we've sort of been headed. I'd say, if you look at the first version of GKE, it's probably more like raw Kubernetes, right? We ran the control plane, but you still did a lot of the work. If you look at where we are now, with things like GKE Autopilot, even things like GKE Enterprise, we're trying to add more and more features for you that we do more for you, right? You want to focus on the higher value, your platform and your sort of applications. Can we take out an abstract provisioning compute, right? Can we take away the need to figure out how to do optimized FinOps by figuring out how many pods to figure on a node? Can we remove that from the equation? And I think that's sort of the core of where we've been going. The other side is, can we make this stuff just reliable, right? We want to earn your trust. We want you to believe that the thing's going to keep running, that your workloads are going to keep running, and that the thing's going to stand up. And as Drew mentioned, that's why we build, test, and do the whole thing from an open source perspective on Kubernetes, on GKE, sorry.
Awesome. And one of the things that really changed in the last while was the fact that GKE itself went from just on GCP to multi-cloud and across a whole range of platforms. What this really unlocked was, one, having that consistent experience across on-prem, which we have to admit is where a lot of the OSS work came from, and probably the small number of gentlemen and ladies that were still running it there. But having that consistent experience, the ability to have observability across wherever you're running Kubernetes, even if you run in other clouds, which would make Gary and I quite sad, but we understand. We want to make sure you have the consistent layer for management, observability, and give that one unified experience. Now, if we fast forward to the ghosts of Kubernetes present, unfortunately, Gary and I couldn't get a budget. There's no special effects. There's no ghosts coming in or anything like that, or puppets, so you just have to make do with us. What we really looked at, let's try, is that, to Gary's earlier point, you don't want to do all that stuff that we had in the chart before. And this has been the big focus of GKE, is how do we make it simpler for you? But thanks to the thriving number of customers using it, the number of contributors, many of you are using a huge number of clusters. And the challenge is that a lot of you would be like, oh, I can manage one cluster. I can manage 2 clusters. I can manage 5 clusters. And then when it gets to 50, you see the tear in the eyes and you're starting to figure out, like, how much work is it to it? It's definitely not something in the past so you could break the curve and be able to manage more and more and more with the same platform teams. This is one of the aspects that we're trying to tackle, where how do we make it easy to manage many clusters from a security point of view, from a governance point of view, from a compliance point of view, because as Kubernetes becomes really the dominant platform for new development, everything managing at scale is critical, and this is where Google's focusing on it and making sure it's as native of everything else that we're doing. Now, quick show of hands, it's early in the morning, and I appreciate everyone showing up, especially considering it's the last day of the conference. I'm not going to make you stand up. Gary may later, he's bigger than me, so I think he can convince you to move around. How many people love upgrades? Okay, there's some people I will no longer trust gambling with for the people who put up their hands. How many people, slightly easier and more honest question, how many people are comfortable with how their upgrade experience is now? Okay, a few more hands. My goal and Gary's goal is next year to get at least half the hands. Because if you get half the hands in upgrades in any software product, that's pretty incredible. But what we focus on is 3 main things. One, fundamentally, is how do we make sure deprecations are mitigated and you're aware of it? Kubernetes moves incredibly quickly, and we want to help you identify that, and we'll speak to that in a little more depth. Second, and this is something we've actually had for a while and pioneered, is be able to roll out upgrades in sequence. The clusters are no longer one cluster. It is literally a fleet, and this is something we've got woven into GKE, but we want to make it easy to be able to deploy this in waves and be able to have a seamless experience on the way you view your business and how you do rollout. And lastly, is give you control on how and when you run your upgrades. If you're a retail client, it's terrifying to think one accidental upgrade may go around BFCM, or if, let's say, you're a major social company on New Year's Eve, we want to make sure upgrades can match when you need to do it with the minimal business impact. So one of the first things, and I'm curious, how many people use release channels right now? Okay, for us, it's around 70% of all the clusters we're seeing are actually on release channels. And the reason why is people don't want to have to go through all the logistics of upgrades. They want something based on the risk. And to be clear, every single part of this bell curve, normally the adoption curve, the most recent bit is the scary fresh bit. But we've got it such that all of these are GA fully production certified versions, but it's really how fast you want to take advantage of the latest and greatest in Kubernetes. If you're looking at Rapid, that's generally coming out close to 30 days after the OSS release. People are like, why can't I have this right now? We want to make sure we do a lot of additional testing and make sure that's rock solid on release for you, because that is a huge part of the value of reliability that Gary mentioned earlier. But I highly encourage you to check out release channels. It is something that we see as just a core part of the value of GKE. Now, one item that I do want to mention is around long-term support. This is something where pushing off upgrades forever is not a good idea, but the business definitely pushes all of us, no matter what industry you're on this all the time. And we'll have announcements coming later this year around this. Our focus has been making sure that all aspects of upgrades work incredibly well and giving back to the community in that regard. But we will be having long-term support coming up, and this will just be an integrated part of release channels, such that it's incredibly easy to adopt and give you a lot of flexibility around this regard. The whole goal is to get half the hands going up and 3 brave individuals saying, I love upgrades. So on rollout sequencing, this has been a big transition for us. It's going from the idea of one cluster to be able to handle many clusters such that you can build the gates in. So I'll sort of randomly point at people. Let's say Dave Bartoletti wants to roll out one cluster, but he wants to check to make sure it's going well. He can build it such that one cluster can get upgraded, a check is part of this, then more clusters, another check. And these checks aren't just based on something we do, but how you want to make sure it's running well. This allows you to natively floor class different teams, different parts of like dev, test, production, but gives you that flexibility such that it really can be, we've probably built with a hodgepodge of YAML and batch scripts, which I typically see in this regard. But this will really simplify things. So with that, I want to hand it over to Gary.
Thanks, Drew. Yeah, one of the, how many folks here have been bitten in the past by an upgrade and you were using a deprecated API? Yeah, so, you know, on the open source side, I guess I would say, you know, Kubernetes has done a better job, well, Kubernetes finally on open source decided to start actually removing deprecated APIs, right? And we actually have set in a much better precedent in the future for like requirements on becoming like real APIs and going from alpha to beta, et cetera. In the interim, we've kind of got this like accelerated rate of deprecations, right? From like, you know, 124, 125, 126, like, through like 130. And so we, you know, want people to be on release channels and want people to be able to trust automatic upgrades. So we thought, well, can we do something to help folks with this? Clearly we know what APIs are going to be deprecated, especially because we're actually usually the ones who are, you know, involved in deprecating them on the outside. So we actually have the ability to look at sort of all the different type of API calls that you're making, right? So with this what we call deprecation insights, the ability to mitigate deprecations, we're actually scanning clusters, looking at active API calls, right? Did you decide to use whatever one of the, you know, ingress beta, right? And do you have anybody who's called that in the last 30 days? We're going to make those, put those up in insights, recommend that you actually move across those. But more importantly, we actually halt automatic upgrades until you actually reconcile that, right? For sort of that 30-day period. The best part is we continue to do this, right? So of course we started this with like, 123 and 124, but even if you're on 125 today and 129 is out and 130 comes out, we're going to show you that if you're using an API in 125, say, that's deprecated in 130, you're going to see that on the roadmap there, such that you'll have time to adjust and make those adjustments in your sort of deployments. So I think this is a kind of a critical feature. And again, we really want people to trust automatic upgrades. I like to say I'm a believer. I have all my demo. I actually run a lot of GKE clusters, and all mine, auto upgrade, and I'm pretty happy with that.
And actually, one point, the amount of information in here actually helps people running the other unnamed Kubernetes distros. We've seen a number of people look and learn from this, even if they're not running on GKE, because it gives you a huge amount of warnings on what you may be encountering on others. So please check it out.
Yep. The other thing, I guess you could read the bullet on the chart, but the other thing that I guess I should mention is that just for folks who may not have been aware, all beta APIs used to be enabled by default in Kubernetes, so in every distribution, so that's why people were able to use those beta APIs, they were just there. Once we started this sort of new rules, any beta API that came out after 124, and the first ones I think were actually in like 126 or 127, those are actually disabled by default. So hopefully between us giving you insights into using the deprecated ones, right, and also now giving more control over which potential beta APIs get enabled so you'll know ahead of time what people are using, we should start to alleviate this problem. By the time we get into next year, hopefully this becomes a non-starter, or not even a problem anymore. One of the other things that we've been working on is sort of like troubleshooting. And sometimes this is maybe for newer people, but I think even when you have your sysadmins and sysadministrators, how many people love the, cannot deploy pod, right? Or pod could not find space, right? We have these super meaningful errors, right? Pod failed to deploy, could not provision compute. Kubernetes is an awesome system, but it's an edge-driven, event-driven, like asynchronous loop, right? So there's not always a tie between, well, you deployed it, that was successful because it validated that your YAML was correct, but then somewhere down the line it fails. And then we give you an error, but how do you start to trace back like what that actually meant, right? If we say failed to provision compute, how do you know if that was quota, right? How do you know if it was we couldn't pull your pod image because there was a security? So one of the things that we've been working on, and I could use the buzzword AI, so I'll partially use it, but we had this even before AI.
I agreed you wouldn't.
But I agreed that I would not, because I don't actually think it's AI. It's just smart looking at events and tying things together. But how can we look at those issues? So we've put together a whole bunch of, how many people have even seen our troubleshooting playbooks in the UI?
Check it out.
Check it out. One other side, Gary's soapbox, is while automation is fantastic, and it's great that everybody uses Terraform and provisions their clusters, I think that if you started, and those of you who've been with us forever, we love it. But I think to a degree, sometimes you miss out on like new stuff that we have, right? Because you don't know that we added these sort of new features, right? So it's always worthwhile to me to take a gander every couple months at the UI or the release notes because we continue to add sort of turnkey features like this. We're going to add more. We will, I promised I wouldn't do it, but we will add more stuff from an AI perspective and chat interface perspective. You've seen some of this stuff with Cloud Assist. So we'll make this same information available via that as well. How can I query when I got an error? What did that mean? And what does that mean in the context of my clusters and my deployments? How many folks here are concerned? Well, whether you're concerned or your company, you may not be concerned. Like me personally, I'm not that concerned about how much my clusters cost Google, but Google might be concerned. Whose companies are concerned with cost today? Yeah, and are all you starting?
People, it's their #1 pressure point from their managements. Okay, so pretty similar number of hands. So okay.
Nice. Oh. I have a good manager. It's not his #1 concern with me. So
we'll talk later.
We'll talk later, though. But how many are familiar with some of the work that we've actually done with cost optimization insights in the UI, and our cost recommendations and that type of stuff? Great. And I guess I'll ask this: how many folks are using things like KubeCost or other open source tools for these things? All right, well, that's good, so you're not in there. So there's still hope for you to use some of the built-in tools here. I think, again, this is straight built into the UI. And what we're doing, we've been doing deep analysis of the fleet, right? So we know all your resources that have been allocated. We published a blog article, I think late last year, on like some simple things that folks do. We found that clusters were massively over-provisioned, right? Because in a lot of cases, people are used to coming from maybe the VM world, right, or the static world, where you can't just dynamically have a new physical server come up, right? You have to have those, so you end up over-provisioning for those sort of cases. And we found that the resources used versus the resources allocated was kind of crazy, right? So with the cost optimization, and because people weren't using things like the cluster autoscaler, or they weren't using HPA and VPA. So what we do here is we give you a holistic view, either across all your clusters, and you can kind of look at all the workloads and just say, here's what was provisioned, here's what's actually being used, right? Then you can drill down on a per cluster level and start to look into the workloads. It goes even further that if you check on this, we start to make actual recommendations for the workloads. We'll actually tell you, essentially, how many folks are familiar with the vertical pod autoscaler? And many people don't use this, but it turns out it has useful information. So we're actually basically running that same algorithm, and we're looking at it, and we're actually making recommendations as to what the pod sizes should be, right? And if you want to go so far, you can actually click it, and you could actually actuate on it, or you could, for example, save out the YAML. Our eventual goal is that you start to look at these things and start to say, hey, these Google guys and girls are making smart decisions, and we want you to basically automatically resize our pods as needed, right, so that we can get better resource allocation. But these tools are available to you today, and that's why we always like to harp on some of these things. Even though we've had these features for like a year, I think sometimes, even though we're an ads company, we don't do the best job at advertising what we do. But this is probably one of our most highly used features. Once people actually find it, they continue to come back to it. On to you.
So the other thing, one of the core areas we've invested very early on, and this is specific to GK itself, is around scalability. And the reason we did this is a great marketing chart. It's always good to have one bar that's much larger. But why this really matters to all of you is that we have really pushed the limits of Kubernetes. We've pushed the limits of GK running across all aspects of hardware at GCP or Google Cloud. As well, we found those edge cases that you shouldn't have to run into. And it's gotten to the point where when we're looking at 10,000 node clusters, and this could be on batch, it could be on training, we've got some really, really large serving workloads as well, we don't even find out about it until it's like, oh, look, this popped up on some other report, because customers aren't even talking to us because it actually just works. And I think the initial work on a lot of this was the serving side. So how do we do analytics? We did work with Bear and looked at really interesting research where the faster you can make it and the more it could scale, the better return it was for the research scientists, and this is where it matters. This ties directly to a lot of the work for AI, because fundamentally this is all about experimentation. So the more you can scale and the more you can compress it down, the more your research scientists, your ML operators can do more and more work and just keep on iterating, and that's where scale comes down to it. But our goal is never hear from any of you. Like if you've got a 25,000 node cluster, please grab Gary and I right after the session, and happy to chat with you. But we want to get it such no matter what you throw at GKE, we don't even know about it because it just works. And that's pretty powerful because that means less work for you and your business can just scale as you go. So on top of that, there's another aspect of scaling. There's single cluster, and that's been a lot of the focus. But for us, it's helping all of you get value and better manage all your clusters. And this isn't just being able to say, hey, I've got a fleet. It's really making sure that security, governance, compliance, observability, cost optimization, you can get a holistic view of everything. We had a great conversation actually this week around chargebacks, and one of our customers was like, hey, I want to look at it by team. Shockingly, it's a bank, right? They're pretty good at this. But leveraging what we've got in GKE now, they are easily able to divvy up by teams, so different business units across dev, test, production, and slice and dice the view of this, not just on the management side, but giving value back to their business, be it auditing compliance, so you can gauge how you want to look at the value there. But it made things simpler for the business to actually manage all of this. And on the platform teams, you can then have one view of all this and be able to effectively run this using GitOps. So this isn't just UI driven. I think the UI view of this and having one unified view of all of this within the GK UI really makes it easy to get going. But we want to make sure you can do this at scale in a repeatable, safe manner. And that's why we've made sure that really this is config as code across everything we're doing here. This is something we announced back in the fall at LastNext. It seems literally like yesterday for many of us. But we're seeing a lot of customers adapt this and move it quickly because it takes a lot of the bespoke code you had, which is difficult, can be brittle, and puts the onus on you for developing. Instead, you can quickly get the value across all aspects of Kubernetes beyond the core in whatever way you want to match what your business needs. Eric?
Yeah, and as Drew mentioned, these sort of fleet-wide operations, how many folks have started to look at the features that we call GKE security posture today? You had a good look?
Good.
It's good. It's good. Again, I'll just go back to please do pop into the dashboard. You're going to see a lot of cool stuff, especially it is next time, so we always have new releases right around these conferences. So you'll see a nice revamped UI. But one of the things that we were trying to do, again, to help folks out is, we know a lot about what's going on in your clusters. Can we provide more information, right? And there were sort of two ideas that we had from a security posture perspective, right? One is, there's just a number of misconfigurations that people may have, right? Or things that we may say should be insecure. And it's very easy to know those as name value pairs. Some folks might have been put in gatekeeper and prevented those things, but what if you didn't in time? How do you go through and how can we identify those? So that's sort of this like workload misconfiguration. We also have the ability to quickly scan actual container images that are cached in your cluster, right? Sort of download and used. You could be scanning in your registries, et cetera, but maybe you haven't updated your applications. Can we give you that view? And again, we're giving you this view across your entire fleet of clusters, right? An individual cluster and across that. As we start to integrate things into things like SEC, and you've probably seen there's some other sessions that you can watch recordings of, generate reports. We're going to have better things for security, audit, compliance, right? Which, as I like to say, will help keep the auditors and the CISOs and the BISOs like off your back, right? And help you get and keep your applications in production faster and longer. So we identified some of those problems, right, with workload misconfigurations, and now you want to prevent them from happening, right? How many folks are familiar with Gatekeeper or running Gatekeeper today? And then how many folks are actually running our policy controller? So there's hope for that too. But policy controller obviously is out there in OPA, open source perspective. How do you prevent certain things from happening, right? Maybe you don't want people who deploy certain images. You don't want people to use, privileged access. What may be, you don't want people to use specific types of compute. Basically any type of policy, right? Any field that's in a spec, you can allow or disallow and sort of have that default. We've got this, fully integrated in there. The other thing that we do is we actually provide a ton of policies out of the box, right? Whether this be for Kubernetes benchmarks, open source security benchmarks, PCI compliance, right? Just best practices, right? They're out of the box. They can enforce that. And again, I'd like to say you kind of get this for free in the sense of you don't have to do any work other than click a button, right, and have these things deployed. Another one, how many folks are familiar with binary authorization? How many folks are familiar with concepts of people installing rogue software that does bad things? Yeah, so one of the other questions we used to get was like, how do I ensure that the containers that are deployed on my cluster have actually been built to the specs that maybe we required from a corporate standard perspective or from a security perspective, right? Binary authorization allows us to do that. You can have your build process. Your build process can say, you have to use these base images. You can't have these vulnerabilities, whatever you want to have, right? And in the end, you require some level of sign-off. And that's going to be signed off, and you'll have a signature. From a GKE perspective, you then just enforce that we only allow images that have passed that process to be deployed, right? This is going to prevent rogue images, misconfigured things from being actually deployed. And again, just a checkbox to kind of enable this.
So Gary led with AI. He broke his promise with his AI headshot, which I still find funny. I can't picture you in a suit. But one of the things that Chaim Goldberg spoke about yesterday was the fact that GKE really offers a unified platform. And I think that's a really important thing to consider. Often as these big step functions, inflection points, insert MBA speak for the transition to AI, it involves a huge amount of work on all of you, right? You're having to build something up from scratch. You're having to start fresh. And that means a mass amount of work for security and a lot of people saying no. This is not the case for GKE. It really is one platform. We're looking at driving this across Kubernetes as well, such that across the entire OSS ecosystem, but in particular on Google, you can leverage the hard work, all the innovations and what's made it work for you at your company for AI as well. Now, our goals are a couple-fold in this regard. Number one is that the actual people doing the AI work, and I don't mean all of you, unless there's a number of AI operators and ML operators here, is they just want to use the tools, the frameworks, what they can hack around with, and not care about Kubernetes. That breaks Gary and our heart. We'll cry in the corner later. But for them, it's important that they don't worry about it. And it's also very important for you. And that's why a huge amount of work we're doing is actually to make sure that frameworks like Slurm, JAX, and others actually work seamlessly with Kubernetes, rather than with traditional VMs. If you want to run on VMs through GCE, great. We highly encourage it, and we've got optimizations on that side of the house as well. But for us, we just want these frameworks to work such that ML operators can think like they've learned and keep going, and you can then optimize to the new reality for that. Second part of this, though, if we go below that level, is actually making sure that we get all the hardware optimally run, and to Gary's earlier points on security, cost efficiency, fleet management, those concepts apply to AI, because a lot of the work around costs is very different. You're no longer thinking of VM costs, hopefully better provision thanks to cost optimization. You're now thinking cost per token. This involves a rethink. Or you're talking about good put versus just overall utilization rates. And these are the things we're now weaving into GKE to make it much simpler for you. And then fundamentally, if you look at what we did with TPU v5, a lot of the network enhancement at A3 Mega, we want to make sure all that technology runs incredibly well on day one, such that you can just get the benefit from it and not have to do the troubleshooting due to the integrations on the Google side, which is incredibly important and something I think our cloud stands out in. Now, one of the things that we've actually had for a while, the image preloading technology we have has been used for just regular serving, which isn't as exciting as AI serving or inference, but this has been something we've seen a lot of the modeling companies, just straight commerce companies, use for a while with these large images with a drastic improvement in performance. This is in partnership with Artifact Registry. If you haven't checked it out, give it a try. It's incredibly easy to use. And we actually saw with Vertex a 29-time improvement in the serving aspect. And that is a fundamental shift to the business. Think about your inference experience. If inference right now takes 29 minutes, you're probably looking for a new job, but that would go from 29 minutes down to 1 minute. But even if it's a couple minutes, that goes from minutes, where you lose clients, down to seconds, where it's a completely different user experience. And that's something we've done in partnership with a variety of teams, and it's incredibly easy to deploy. Secondly, we're looking at making sure that all the different GPU types out there are optimized for GKE. Such as the NVIDIA L4 GPUs, we've actually seen a 50% improvement moving from one VM family to the other. But this is indicative of the optimizations we're actually doing at the hardware level within Kubernetes itself and with the GKE. So no matter what comes out, we are at the bleeding edge, which means you can be the bleeding edge of using the latest, greatest, and getting the best performance out of this. Now, one thing I'm incredibly proud of, and this speaks back to that 29%, or 29% would not be as great a metric, 29-time improvement, is the work we're doing with Vertex. Vertex is a fabulous managed platform where all the ML ops, training optimization, serving optimization is integrated into it, and we're proud that much of Vertex actually runs on GKE. And the improvements we made in inference, improvements we continue to make in training, directly flows into Vertex Firks, and soon into the external customers to make sure their platform is improving as quickly as all the hardware and Kubernetes offerings are as well. So if you're looking at ML on GKE, definitely encourage you to check out Vertex and figure out how smoothly you can mix and match and find the best mix for you, because a lot of the work they're doing means you don't have to do it, and your ML teams can just build models and iterate on them, and you have less platform work to do. Now, one other thing that has changed a lot. So we're doing a show of hands. It's early in the morning, so we appreciate the patience. How many people think Stateful on Kubernetes is easy now? Okay, keep those hands up. We're gonna a little bit of exercise. How many people are running Stateful on Kubernetes despite that? And this could be Kafka, this could be DIY databases. The people with your hands down, you're actually the exception. We've seen a massive upswing in stateful workloads of a whole variety of types, not just traditional batch. This could be your own databases. This could be streaming. It could be anything. because of the advancements we've actually done on the Data and Kubernetes Initiative, which is a great community effort and one we've been heavy participants and members since the very beginning, we've constantly been looking at how to make upgrades easier, how to just have this built into GKE such that Stateful just works. I think that's fundamental what Gary spoke about earlier, but this is a big area of improvement, and we encourage you to check it out. Google has a lot of great managed offerings in this space from Spanner or BigQuery, but many of you want to do customizations, or you bring over legacy or classic code in this space, and it is much simpler at this point. You'd be surprised how well it works, especially if you haven't checked it out in a couple of years. One thing, and this is one GKE, that we are incredibly proud of is it is one platform. Everything we've spoken about today, from fleet to security to cost optimization to teams to chargebacks, it is all woven in a single GKE platform now. There is Standard Edition, which is everything you've known and loved about GKE in terms of the ability to fully customize it, but our Enterprise Edition really is expanding all the capabilities at the upper level of management, cost optimization, security, and the value of things that you no longer have to do yourself to be able to manage a system at scale and get a huge amount of value quickly. I encourage you to take a look at Enterprise, but to Gary's earlier point, if you haven't gone on the UI or played around with the new APIs, we've made sure this just works as one unified platform versus two distinct different products. And this is a big change for us and one that we definitely encourage you to take a look at. So with that, Gary's going to dress up as a ghost of future GKE, but no, he's not. But we wanted to give you a peek into what's coming.
Great, thanks, Drew. So this is probably the feature that I've been most excited about in my 3 years here, for whatever that's worth, and I'm a tough critic. So how many folks are using cluster auto-scaling today? Great. How many folks are using node auto-provisioning today? How many folks know what node auto-provisioning is? OK, so one of the, real quick, why I'm very excited about this is, so cluster auto-scaling has a few, cluster auto-scaler, great, couple limitations. You have to have cluster auto-scaler only works on existing node pools, right? So you have to figure out what kind of compute you want. You have to provision it. If a team decides they want some other compute, it's usually going to be a request, and you have to create another node pool. And then we have, node auto-provisioning, which we have today, for those of you who didn't know, is the ability to basically, we'll create node pools for you on the fly based on, a tag or compute that you can actually create in there. What you can't do today is actually give hints or control to the cluster auto-scaler. So we have a lot of people, especially the two-letter word that we talked about earlier, but use cases where people want to use spot compute, right? Because spot has great price. But you're like, hey, I want to use spot. But if spot's not available, I want to use on demand. But then at some point, if spot becomes available, how do I go back to spot if my workloads can tolerate that? So the idea here is we're creating this thing called custom compute or compute classes. And in compute classes, you'll be able to, as you can do, you can make a definition of how you want the autoscaler to work, right? What's your preference of compute? So in this example, I think we said you could use N2D 16, standard 16 as spot, right? Then you could do N2 on demand, right? And essentially what happens is you'll say on your deployment, you'll just tag it that you want it to use this compute class. And then depending on if that compute's available, we'll use it in that priority order. There's another option which allows you to what we call defrag, which will say that we'll actually go look at, say the pod wanted whatever the N2D 16 spot, but it ended up on generic compute at the bottom. We'll periodically reconcile, and then we'll go back through and figure out, hey, this is actually available, and if you allow us to, we'll actually move those workloads. This is going to be, I think, one of the key game changers, for us, right? Because people have been looking to have these hints. You want to use your CUDs, your custom contracts, whatever it may be for your workloads, right? So this sort of bridges the gap between some of the deficiencies we had in NAP and some of the things that you can't do with things like preferred during scheduling, which just don't work from an affinity perspective. What does it look like? This is kind of a spec. It's also going to be nice because now you won't have to create necessarily node pools via like a node pool API or whatever. It's going to be a CRD, right? So this can be provisioned just like you do any other type of Kubernetes resource. You can create as many of these as you want. And then you simply, as you can see from the deployment on your right, you just specify from a selector or a label that you want to use this compute class. So super excited about this. This is in preview, private preview now. So if you're interested, call Drew, and we'll hook you up. No, just let us know or contact your rep.
I'm going to give you Gary's cell phone number to be clear, though. So when you call, it's actually going to be Gary answering.
Yeah. The other real quick, because we're running out of time, so the other one, have folks heard of dynamic workload scheduler? So one of the other big things, and again, this is typically for the AI workloads, but it's also big in batch, any off-type stuff. Look, while we could have infinite compute, we don't always have infinite compute. The idea of a dynamic workload scheduler is that maybe you don't necessarily need to run your job or your large training or batch job right now. You're willing to run it sometime in the future. And that can be a specific date, or you can kind of have it random, and put it in there. And the idea here is that we can now provide extra capacity, right, if you're willing to kind of wait for it. This will work for GPUs or non-GPU workloads. From a GKE perspective, this is tightly integrated with a product called Q. We've made this experience super fantastic, as we said, to make it super easy. Should also be noted that if you want to use this with GCE batch or just GCE VMs, you can as well. And as Drew mentioned earlier, the Vertex team is very excited to take advantage of this as well, since Vertex is sort of built on top. So this is going to give you, maybe you don't have to use a reservation today and buy a ton of GPUs. If you just need to run something within the next 30 days, this might be like the perfect feature for you. It's available, I forget if it's somewhere in between preview and GA, maybe GA.
It's GAing very, very soon. Date TBD, but soon is soon.
Soon, but it does work in preview, in public preview today, so try it out.
Check it out.
And then this is kind of some cool stuff that we're doing on AI/ML. This sort of idea of, how can we figure out how to serve things in the order that they come in. So many people know that like Kubernetes is, again, asynchronous. Stuff comes in the scheduler. It'll figure out, it looks at it, can I schedule this pod? No. Can I schedule this pod? Yes, schedule it, right? And then, trigger compute, but there's no guarantee of sort of that order of things. So what if you want to orchestrate that I want things to actually go basically in the order of arrival and make sure I tightly optimize for that? That's flex start mode, so that'll be coming soon in the future as well. We do put this for ML, but obviously these things just become core of GKE, so you can use them if you have these use cases outside of ML. You can definitely use this as well. And then how many folks are using things like, interested in like, high performance storage, have big needs for storage and things like that? Are you familiar with like parallel store and other types of like technologies that are out there? If you're not, these are basically, multi-parallel read-write systems for high-speed storage. Again, normally going to be used in batch, your ML jobs, for sort of stateful and training jobs. From a Google Cloud perspective, we're building a massive parallel store from a storage perspective. And then from a GKE perspective, our job in life basically is to create the best orchestration on top of all cool GCE features, Google Cloud features. So we will have a CSI driver for this and make this like just easily natively integrated and orchestrated into your workloads. I guess you can, if you liked what we said or want to talk to us again sometime in the future, feel free to grab this QR code. Ask a couple of questions, and we're definitely willing to reach back out to you. And then I think we have our normal, your feedback is greatly appreciated. And with that, I think we have one more slide, Drew. Yeah. I'll see you.
Thank you very much, Gary. So one of the coolest things, as I mentioned earlier, is Kubernetes is actually turning 10, which is incredible. And this is thanks to all your contributions. And if you just look at how much GKE has changed the last 9 years, it's pretty incredible. We will be having a series of events leading up to this in partnership with the CNCF, culminating on June 6th, as well after that regionally across the globe. So if you follow the Kate's Turns 10 hashtag, there will be a lot of announcements around this. But this is a huge achievement when you think of how many software products have actually lasted 10 years and continue to thrive. We view this as actually the first 10 of 20 because AI is really driving us to the next level of Kubernetes, new flexible hardware patterns, and we expect to see Kubernetes turns 20 in about 10 years' time, but check out the hashtag. Thank you so much to all of you coming, and please check out GK Enterprise as well. We've got a trial system, and it's pretty amazing what you can already see, so check it out. Thanks, folks. Have a great conference.